So we'll start with the second week topics today. The first one of them being QTA 4, multivariate random variables. Okay. So what are multivariate random variables? So we are just extending the idea of univariate random variables or single random variables so that we can include the interactions or dependencies between two or more univariate random variables. Okay, so each component, of course, of the multivariate random variables, each component is actually a univariate random variable. Okay, so the example is bivariate random variables, and we'll see the example of bivariate with some numbers after a few slides. So just like univariate random variables, multivariate random variables are also, they can also take either discrete values or they can take continuous values. Okay. And again, the notation is same, capital uppercase letters for variables and small letters for realizations. Okay. Now, if you remember, we had for discrete, which function we used to have for the probability density or probability mass. What was the function? PMF or PDF for discrete?
PN,
Correct.
PMF.
PMF. And for continuous, it was PDF. Correct. And CDF was applicable to both, right? The only difference is that in the first case, it might be known as cumulative distribution. In the second case, it is known as cumulative density function. Okay. But the idea for behind the CDF is same, less than or equal to the uh, two realizations, right? For X1 and X2. We'll see that. We'll see an example and you'll understand it properly. Now, as I said, we'll start with bivariate random variables. So see, multivariate random variables, as we discussed, there are components of it. Okay, and since this is bivariate, we are talking about two components. So it is a vector. It is known as a vector with two components, x1 and x2. Either you can write it like this. Okay, this is just a representation. In fact, the proper mathematical format will be like a vector or matrix notation like this. Okay, so x has two components, x1 and x2. And the realization of capital X, which will be small x, which will be denoted by small x, it also has two component values. Okay, like this. So x1, small x1 is a realization of capital X1 and small x2 is a realization of the second component, capital X2. Okay, so this is the PMF. Similar definition. PMF basically, earlier it was Fx is equal to probability. Now here also the PMF tells the probability of x1 being equal to x1 and x2 being equal to x2 at the same time. Okay. Now what is CDF? CDF is the same idea. CDF of any bivariate random variable is a function returning the total probability that each of the two components is less than or equal to a given value for the component. Okay, so let's take example of the representation. So let's take an example where say we have x1 is 2 and x2 equal to 5. Okay, I was given a recommendation by one of the students last time that we should try and change the numbers, although it has not been possible in some cases, all the cases. But some of the cases we have done it this week. In fact, we'll make it better and better from the consecutive next few weeks. Okay, where we'll try to revamp the PPTs in a more holistic way and especially with related to examples. So yeah, but even in today's class, say for example, this one, we have discussed a different case as compared to the video. I mean, where we're talking about conditional probability, the case and the numbers will be different. Although the example construction is same. The initial numbers of the example are same, but the case will be different. So, okay, let's come back to bivariate. So let's say we have x1 equal to 2. There are two components, of course, and these are the two realizations. x1 is 2 and x1 is 5. If I tell you that the probability of x1 being equal to 2 and x2 being equal to 5 is 11%, okay, or something like this. F2 comma 5 is 11%. How do I represent it? On the axis, how do I represent it? How many axes were required to represent a univariate random variable's PMF? How many axes were required? Two axes, x
Two.
axis, yeah, correct. X axis and y axis. So what do you think? How many axes might be required to represent a bivariate random variable?
Three.
Correct. Three axes.
Hmm.
Okay. So we'll have two axes for the two components x1 and x2 and the third axis for the PMF value. Okay. So obviously till bivariate random variable at least we can represent them physically because we can represent three dimensions on a three-dimensional space. But if we are asked to represent a trivariate variable in a 3D space, that won't be possible. Of course, mathematical representation can be done, but visual representation won't be possible. Okay, we'll have to have some tweaks. Even then, it will be just a proxy. It will not be a full-fledged 4D kind of diagram, right? Okay, now let's say, as I mentioned, that x1 is 2 and x2 is 5. So first we'll see what is x1. x1 is 2. So we'll join 2 and 5 and we'll see in the x1 x2 plane where this point is, where you have x1 equal to 2 and x2 equal to 5. So this is the point on the x1 x2 plane, which is 2 comma 5.
Hmm.
And of course, since it is on the x1 x2 plane, the z coordinate, the third coordinate you should say, it is actually 0. So this is 2 comma 5 on the plane, but as of now the third coordinate is 0 because it's still on the x1 x2 plane. Now what you do to find out the probability which will be represented by the third axis, what you do, you actually raise this point by how many units or what distance? By a distance of 0.11 above. If this is the ground, if f1, if x1 x2 plane is the ground for us, then let's say the ground, the floor of our room, okay, then we'll move a little bit up above towards the ceiling, right? It will be a very small height although, but still we'll move a little bit up, okay, approximately in fact exactly 0.11 distance up, and this will be the coordinate on the z-axis or the PMF axis. So this axis, actually the z-axis, vertical axis, it represents the PMF values. Okay. To be precise, see, sometimes there will be implications and you will understand that, okay, when I write F, we are talking about actually F x1 comma x2, right? Okay, so this is what we are talking about, x1 comma x2. So generally, basically, f is the function. That's why even if we are writing f, that is sufficient. Now, what is a trinomial distribution? Trinomial distribution is an example of a discrete bivariate random variable. It is an example. Now, a little bit, the nomenclature is a little bit counterintuitive, you can say, because just now we are talking about bivariate. So how you'll ask that trinomial can be an example of bivariate. Just like binomial was an example of univariate, right? Because there are two outcomes. In binomial, there are two outcomes. So how come it is univariate? It is univariate because if one of the outcome happens, the other will not, because and the other will not happen. Only two outcomes are possible. Either the bond will default or the bond will not default. Okay, so that is why only one variable is enough to model those two outcomes, and that is why, if you remember, if we have the probability of success as p, we don't need to have a separate variable. Okay, we just define q is equal to 1 minus p, or the probability of failure is equal to 1 minus p, just for convenience, but actually we don't need it. Q is implied from p only. Okay, just like the not occurring of one of the events, like for example no default, okay, occurs from, or it is implied from the occurrence of the other event or default. Okay, so both are, you can say, mutually exclusive also, okay, and kind of exhaustive also, because there are only two outcomes in that experiment. So if we have an example as trinomial distribution for bivariate random variable, we can have like this. We can have n independent trials, and since in binomial there were two outcomes, over here we will have three outcomes. So for those three outcomes, we actually need only two components. Okay, where the first component is the number of realizations of outcome. Now, this is something which can be, again, I'll say GARP has not paid a lot of attention over here to maintain consistency, because if you remember, uh, small x1 was denoted to actually represent the realization. Okay, so remember that x1 is the number of realizations over here. X1, capital X1, is the variable which denotes the number of realizations of outcome 1. X2 is the number of realizations of outcome 2. Okay, and n minus x1 minus x2, or n minus x1 plus x2, by default it will be the number of realizations for outcome 3, because we do not need x3 separately. Let's say we model this as x3 only, but x3 is being implied from x1 and x2. Okay, so that is why I was saying that, I mean, they should have mentioned a little bit of small x1 and small x2 also over here, although this is not wrong. Again, I'm saying they have just to maintain consistency, it is always better to define all your variables and their realizations properly in each and every example, in each and every subtopic also, so that it is consistent. But anyways, that won't matter much. It's completely okay as of now. You just understand that this is about the number of realizations. So what is, I mean, what can be the practical benefit of such kind of a distribution, where this kind of a distribution might be used? So if suppose there is a bank, okay, which is trying to analyze customer loan applications. The total number of applications, say, are n, which are being analyzed right now. Okay, so either they can be any three outcomes. Tell me which, whoever, those who are working in the, especially on the credit side. If suppose I have to review loan applications and I have to set three outcomes for those results, either it can be approved can be one of the outcomes, right? Of course, denied can be the other outcome, and another third outcome can be pending review. Correct, that is possible. Maybe you are reviewing it and you'll take a decision after the review. So as of now, the application status can be either approved, denied, or pending review. So this capital X1 will be the number of approved applications basically. This capital X2 will be the number of denied applications. And the number of applications still pending for review, or X3, it will automatically become n minus X1 plus X2. That's the idea. Okay. Now, what are the parameters of this trinomial distribution mathematically? Mathematically, of course, we have n, just like it was there in binomial. N. Okay. How many parameters were there in binomial? Two. N and P. Do you remember that? P was the probability of success. Correct bunch. Approved, rejected, on hold. Yeah, I saw your message now. Just like that on review. Correct. So N is the total number of experiments. Then you have P1, which is the probability of observing outcome 1. And P2 is the probability of observing outcome 2. So without any doubt, the third probability can be implied from the first two probabilities. It will be how much? Can you tell me, if I want to find out the probability of, say, outcome 3?
1 minus
Very good.
P,
Correct.
P1 plus P2.
Correct. Correct. Everyone is correct. 1 minus P1 minus P2, or you can also write 1 minus P1 plus P2 inside the brackets. Okay. So it is implied. We do not need it, but for the sake of convenience, we'll just write it. Okay. So as to make our formulas look a bit easy to digest and easy on your eyes, I should say. Okay, now, so this is the PMF. This is what I was talking about, easy on the eye. So, and if you have 1 minus P1 minus P2 over here, it might be a bit difficult for you to remember sometimes. So if you have P3 and X3, okay, then I think your job becomes a bit easier. So this is how I prefer to remember it and as well as represent it. Automatically, these two will be implied, P3 and X3. So we can take an example. Let's say you have 8 applications. Okay, total 8 applications, and out of those 8 applications, uh, in general, independently, 25% of the applications are expected to be approved. 60% of the applications are expected to be denied. Okay. So I need to find out that out of eight applications, what is the probability that one was approved and five were denied? Okay. So obviously, if one was approved and five were denied, it automatically implies that two were on review. Okay. Because one plus five plus two is eight. So tell me, how will you find it? What should be the first step? What should be the first step? Of course, the first step will be to find out these two, x3 and p3, because we have to plug them in the formula. So the number of applications which will be pending for review or x3 will be 2, correct? Based on this information, if one is approved and five are denied, obviously two will be under review. Then what will be the probability of any application being held for review? Can you tell me quickly? P3. The probability of any application being held for review. What will be the answer?
0.15.
Correct, 0.15. So there's a 15% chance of any application held for being held for review. Okay. So we'll just plug in these parameters inputs into the formula, and this is what we get. F1 comma 5 is equal to 8 factorial divided by 1 factorial times 5 factorial times 2 factorial multiplied by 25% raised to the power 1, 60% raised to the power 5, 15% raised to the power 2. Please send your answers via private chat. Please send your answers via private chat. There is an option of private chat. So send it to me privately using the private chat option. Okay, so you'll see that on Zoom chat. Okay, you have an option of messaging everyone, or you can change it. Direct message, or you can just simply click on host, the three buttons on the host, and you can just send a direct message. Is there an option to send a direct message by clicking? No. So you have to click against. Just a minute. Message. Everyone option is there. There used to be an option of private chat, right? On Zoom meetings. Just give me 1 minute. Yeah, it's there now. Who can see your messages? It's not changing. Hi. There was a default option. We used to select, right? Whom you want to send. Are you able to see it? Private chat. If you're not able to see it, no problem. You can just. There's an option participant can chat. In fact, I have to change it actually. Participant can chat with hosts and co-hosts. I can, yeah, got it. Got it. Got it. Got it. It's there. Private message. Got it. Yes. Okay. So one of the answers I've got, probably uh, the first answer that I've got, probably a decimal place has to be checked. Okay. Second answer is most probably correct. Just now I got the second answer. Most probably correct. Please send your answers. So once just check the decimal place. Pooja, your answer is correct. I'm waiting for others. Ashima. Okay, some of you have also sent directly in the public chat. Okay. I'll not reply right now whether they are correct or not. Private chat ones I'll reply. Public chat ones I'll reply later on. Okay. Come on, Ashima. Abhishek has sent. Aviyank, try sending your answers. Don't worry whether it's correct or not. Don't worry about that. Just try and calculate and send your answer, whatever you have got. See, I said this earlier also. I'm saying this again. One of the benefits of the live classes is that we get a chance to solve the problems together in the class, and the calculation part is also enhanced. Okay, because obviously, although it's not a very high pressure environment like the exam, but still, as compared to individual study, when you are studying alone, that is, psychologically, you are at, I'll say, most peace of mind in terms of your focus and in terms of your calculation speed, whatever. But in this case, since you're doing it with the class, it will probably uh, give you a little discomfort sometimes, not always, of course, but that is how we need to practice, right? So Aviyank, pending, your answer is pending. Bukula, your answer is pending. Garima has sent. Hashima has already sent. Abhishek has sent. Gaurav, your answer is pending. Meenakshi, Nitin, Parth, pending. Pooja has sent. Rajlakshmi, pending. Srija, pending. Shiva has sent. Ujjwal has sent. Vansh has sent. Vansh was the first one to send. So, yeah. Okay, so Garima, correct. Ashima, correct. Ujjwal, correct. Okay, correct, Vansh. The issue was only with the decimals. Okay, fine. So, I have reminded everyone, okay, try and solve and just try and get your answer. If you're not getting it right now, at least try after the class immediately. Okay. And let's be as active as possible in the class. So this is the correct answer. Those who have got 7.35% or 7.348%. Okay. This is absolutely correct. And generally, you see, these kind of distributions, you can never get an answer as high as 73%. So once you get 73%, you just question yourself. If you're talking about a trinomial distribution, and this will happen out of so many possible outcomes, obviously the probability will be not very high. Okay, next, joint probabilities. So when we talk about discrete distributions, okay, even in the previous case, what kind of probability we were seeing? It was like a joint probability only, because we were seeing probability that one application will be approved and at the same time five will be denied out of those eight applications, right? So in that same experiment of eight trials. So discrete distributions, when we are talking about, okay, we can define them using some particular values, and we can represent them using a probability matrix. Okay, just like a table. This is a table, okay, or a probability matrix. Now what do these numbers mean? These numbers actually denote joint probability. So what we have done in this example, as I said, the example is same as the video, but we'll analyze a different case as compared to the video. Okay, I think one more answer was given earlier. It was by Nitin also. Okay, yeah. Okay, got it. Bianca has also sent now. Great. Very good. So what we are trying to do, okay, we are trying to model stock returns with analyst ratings. So obviously, this is quite obvious that when you analyze the stock returns, ratings is definitely one of the events which will influence the returns without any doubt. Okay. So in this case, we can clearly see that these two events are dependent on each other, although that is not the point. And for this particular example, we are not discussing about independent or dependent events. That will be discussed later, not now. For the same example, independence part will also be discussed later. But right now we are seeing that, okay, fine. These are two market variables. One is of course ratings, the other is return. So let's see what are the joint probabilities of stock return being something and analyst rating being something. Let's first analyze that and then we'll come to the conditional part, independence part later on. So for example, I mean this in this case, we are seeing that the return on any company stock, it can be related to the rating given to the company by the analyst, and we are assuming that only three possible outcomes can be possible in terms of returns. Also, only three possible outcomes are possible for analyst ratings. Okay. It is not necessary, although, that you have to build a probability matrix where the one first variable and second variable have to have the same number of outcomes. It can be 4 for stock returns, no problem. It can be anything for, in fact, in most cases for analyst rating, it will be negative, neutral, and positive most of the time, but still, you theoretically you can build more. So we can have either the stock return being negative 5% or 0% and 5%. Okay. And analyst ratings, either they can be negative, neutral, or positive. Okay. So what do these numbers mean? What do these numbers mean? These are joint probabilities. So for example, if I talk about this 15%, this one, center one, it means that probability that analyst rating will be neutral, which means it will take the value 0. The 0 is just a number we are using to model neutral, nothing else, nothing special about it. Okay. So analyst ratings will be neutral and the stock returns will be 0%, is 15%. Similarly, if you want to model this 20%, so the probability that the analyst rating will be positive and the stock return will be 5% is 20%. Okay, so it's just like that. Joint probabilities. Now, let us come to marginal distributions. So, the distribution of any single component of a bivariate random variable is called a marginal distribution. So, marginal PMF is simply a univariate PMF. Same example we can have. This one. Now, what we are doing? If you want to find out, see, earlier what we were doing when I had to model this, say 15%. Okay. So, what I said, f x1 being 0%, and x2 being neutral, which means 0, neutral is 0, right, is equal to 15%. All these are joint probabilities. Okay. Over here, if I only want to find out the probability that stock return is, say, negative 5% only, without even considering the ratings. Okay, so there we are talking about marginal distributions because we are only considering a single component. The distribution of a single component is called a marginal distribution. Okay, that is why it is a univariate PMF. We are talking about a single component. Now, what you do to find out the probability of a single component, you actually sum all the joint probabilities in a particular row or column. How? Let's take an example. Let's see if we want to find out the probability that stock return is negative 5%. That's it. So what is the answer? This is the answer. 20 plus 10 plus 5, which is 35%. Clear? Similarly, can you tell me the probability that analyst rating will be neutral? That's it. What is the probability that analyst
40%.
rating? Correct.
40.
Absolutely. So we just sum across the second row. Analyst rating being neutral is, you can see 10 plus 15 plus 15 is 40%. Okay. The oval can be represented better. Okay. It should be from 20 from here. Anyways, no problem. Okay. So this is the idea. Then, okay. What about the stock return being 30%? Sorry, stock return being 0%. I'm really sorry. I by mistake
30.
30. That is the answer actually. Stock return being 0% is 30%. This one 0% is the second column. So 10 plus 15 plus 5 is simply 30%. Okay. So this is the idea. Similarly, x1 is equal to 5% is 35%. So all the outcomes, if we want to have the marginal probabilities of them, we can just add across the rows and across the columns. So you see we have these 6 marginal probabilities. Okay, because we have 3 from this side and 3 from this side. Okay. Now, the marginal CDF is exactly defined in the same way using the marginal PMF, so that this is the definition. Basically, x1 being less than equal to x1, a single component we are talking about. Okay. So if you want to have the marginal probability that the return will be 0% or less. Yeah, just a minute, Nitin. We'll go back. So Nitin is asking what 100% represents on the previous slide. 100% is the sum of all probabilities on either side. No, on either side, not on both sides, on either side. Now, what I mean by this is that, see, since Nitin, you know that the stock return can be either -5 with a 35% probability, or it can be 0 with a 30% probability, or it can be 5% with a 35% probability, right? Only three outcomes are possible, correct? No, we'll not say combined marginal PMF. We will say it represents the probability of the sample space. Okay, Nitin, why? Because only three outcomes are possible, Nitin, correct? For the stock return. Agreed? Just like in a throw of a dice, only six outcomes are possible. So if you add the probabilities of all those six outcomes, what will you get?
Total probability.
How much? Total probability, which is how much? One, correct?
Yeah.
100%, right? If
Yes.
you add the probabilities of all the individual outcomes, you'll get 100%, correct?
Yeah.
So that is the idea. When you
Okay.
add the probabilities of all the possible outcomes for the stock return, you have to get 100%. Okay, and this is true on all sides. Okay, that is why I said either of the sides, not both, because you cannot add all these three plus these three will give 100. No, this
Yeah.
100 is independent. Okay, this is separate, and this will also be 100 without any doubt. Because if there are only three possibilities for analyst ratings, if you add all the three possibilities, obviously you'll get how much?
One.
100%.
Yeah.
Got it? Okay, so when I say please answer on private chat, only then answer on private chat. For these common discussions, we can always go for the main chat. Okay, so when we are solving a question, we'll go for private chat. For general discussions, let's go for the main chat. Okay, fine. So, Nitin, clear? What is the idea behind 100%?
Yep. Yep.
Okay.
Thanks.
It's actually a very good question because see, these things actually should be asked. If you feel that okay, some point has to be discussed or something was probably overlooked or because it was too obvious or too simple, still you should ask it. Okay, especially if it's not clear in your mind. Now, if I want to find out the probability of return being less than or equal to zero, less than or equal to zero. So it will be either -5% or 0. That is the part which is representing less than or equal to 0. Okay. So to the left of 0 basically. That is how we used to find out the values for the cumulative distribution function, right? To the left of a particular value. So to the left of 0 and including 0, of course, you have how much? 30 plus 35. 30 plus 35, correct? Which is 65%. Okay, Nathan, 65%, not uh,
No, I
7.
was I was on horizontal line, not the
Okay, okay,
vertical.
okay.
Yeah.
So yeah, you were actually counting these two, right? 30 plus 40. Got it. So it will be 30 plus 35. Okay, fine. So this is the same idea of cumulative probability. Now, conditional probability. You can see this definition. X2 is equal to X2 is given. So this is given that X2 has taken a value of X2. This is given. Okay, so this is exactly, you don't even need to remember this actually separately. Notations, in fact, in this chapter, in multivariate, notations are not at all important because everything you'll be able to relate to the first session that we have had, the simple structure of the formula. So this is exactly same as this. There's no difference. So in the numerator, you have joint. In the numerator, you have joint of A and B. And in the denominator, you have marginal of B. Okay. In the numerator, you have joint of A and B, and in the denominator, you have marginal of B. So consider the same example now. Okay. So what we can do, we can try and find out some conditional probabilities. First, what we'll do, we'll see what is the probability. Let's take, I said we'll take another case. Okay. So in the video, the analyst rating of negative case has been taken. Over here, we can take the case of analyst rating being neutral. We can find out all the conditional probabilities based on the second case. Okay, so that we can have new numbers. Now, Marginal is quite straightforward, right? 40%. For analyst rating being neutral, the marginal is 40%. So the denominator marginal will be common given x2 is equal to 0. If we want to find out anything regarding x1, any probability, then the denominator will be the same. So let's come to some numbers. So we are assuming that analyst rating is equal to neutral has already happened. So the analyst has already given a neutral rating, and for that the probability is 40%. We have already found out just now. Okay, from the table directly, it was given. So if I want to find out the probability that the stock return will be negative 5%. So the first outcome I am considering now, this one. Given that the analyst rating is already neutral, if I want to find out that the stock return will be negative 5%, given that analyst rating is neutral. So denominator we have already found out 40%. Numerator will be joint probability of 10%. Numerator will be the joint probability over here. Okay. So this is the intersection of this and this. X1 being equal to 5, negative 5, and x2 being equal to 0. This is the intersection, 10%. So intersection divided by or joint divided by marginal. So what you'll get? You'll get 0.1 10% by 40%, which is 25%. Similarly, can you tell me what is the probability that stock return will be 0% given that analyst rating is neutral? I'm again going back to the previous slide. Understand my question, understand the first calculation, and then tell me what will be the probability of the stock return. Again, this should be on private chat. This message should be on private chat. The probability of stock return equal to 0% given that analyst rating is neutral or x2 equal to 0. Okay, so this is the table. Tell me, send me the answers via private chat quickly. Siva, check again. Punch correct. Ujwal, check again. Aviyank, correct. Absolutely. Nitin, correct. Ashima, check again. Shiva, correct now. Absolutely correct. Pooja, correct. Abhishek, I think by mistake you have flipped two numbers. Your answer, you have calculated it correct, I'm sure. Okay, just by mistake you have flipped two numbers. So it's correct. Okay. No, Ashima. No, 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 no. Why 30? The denominator will be 40 only, Ashima. Understood? Denominator is the probability that x2 equal to 0. So that is the same. Okay, Srija, correct. And Ujwal also correct. So let's see. See, Ashima, we were able to find this. Okay, what we have to find now? We have to find this. So it is 15% by 40%, Ashima. Understood why 40 in the denominator? Because given that x2 equal to 0, and for given that x2 equal to 0, the marginal probability is 40% only, not 30. Got it? Okay, so that's the idea. Similarly, what will be the answer for x1 equal to 5% given that x2 equal to 0? Again, given that is same. That's why I said denominator will be same in all cases. Again, it will be the same. It will be 37.5% because 15 is here also. You can see this is also 15 and this is also 15, right? So in the second case, 15 was in the denominator. This 15 was in the numerator. And for the third case, this 15 was in the numerator. So obviously the answer will be same. But but do we even need to do the third calculations once we have the first two outcomes? Think about it. Do we even need to do the third calculation once we have the third? No. We can simply find out. We don't even need to perform this separately in terms of conditional. Because once we have 0.25 and 0.375, we subtract their sum from 1 and we get 0.375 again. So it's the same thing because the total probabilities need to add to 100%. Okay. Now, one thing which I want to discuss over here is, see, but one thing which I want to be very, very clear about, and you guys should also be very clear about, is what is the meaning of conditional probability and what is the meaning of conditional distribution. Okay, this is also something which is overlooked. The distinction is overlooked, and candidates are sometimes not very clear when we are talking about distribution. So, in this case, what is the distribution? See, conditional probability, these three are conditional probabilities: 0.25, 0.375, 0.375. But if we take them together for all possible outcomes, it becomes a distribution. Okay, so basically distribution is just representing all possible probability. So in this case, this is the conditional distribution, the conditional probability mass function for x1 given that x2 equal to. So basically all three probabilities when you take them together in a table, in this case, that is your conditional distribution. Okay, these are individual conditional probabilities. So just make sure that this idea is clear because when we say discuss about say finding out expected values, conditional expectations. So for normal expectations, use the mean distribution, right? Probability is given, outcome is given. You can find out the expectation by just doing summation pi xi. So even in conditional expectation, you will do summation pi xi only. The only difference is that in conditional expectation, you will use the conditional distribution. This table, not the original table. Okay. So we'll see the example later on also. Now come to independence. So again, this notation not required to remember at all. It's exactly the same as this. If two events A and B are independent, PA intersection B is equal to PA times PB. So if two components x1 and x2 are independent, then their joint probabilities is equal to the product of the marginals. Okay, so let's write it. Joint is equal to the product of marginals. Okay, so if this is the same table, okay, sorry, this is not the same table because in that earlier table, that condition would not have been satisfied. So we have just for this particular, Nitin, before we move forward, Nitin has asked, yes, Nitin, actually, no. In this case, uh, yes, it is understood, but we are not concerned about that actually, Nitin. Okay, we are not concerned about that. In this case, if you see, the there is a slight, I'll say, perception error. I'll not even say misconception, I'll say perception error. Because see, don't consider that we are talking about two outcomes. Like for example, if analyst rating is negative and or neutral, then the third outcome positive is implied. Actually, it's not about that. So if we were talking about that, then you are right. But in this case, we are talking about the components themselves. It means what are the two components? We are talking about stock return x1 and analyst ratings x2. So there are only two components. There is no third component, Nitin. Understood? That is the idea. So just a small perception error over here. Got it? Okay. Now, in this case, we have tweaked only for independence example. We have tweaked the numbers just like in the book. So these numbers have directly been taken from the book and very smartly these numbers have been constructed by GARP. Why? Because we want to check whether the two components are independent or not. So independent means product of joint, sorry, product of marginals should be equal to joint. So first let's find the marginals. Okay, then we'll find out their product. Let's find out the marginals. So how to find out the marginals? Of course, we'll add across the rows and columns. So if we add these three, what do we get? What will you get if you add these three? What will be the marginal probability of x1 being equal to negative 5%? Correct. 35. So this is 35, 30, and 35. Similarly, if you add across rows, you get 30, 40, and 30. And of course, on either side, the sum will be 100. That is not required in this case. So if I want to find out the marginal probability of x1 being equal to 0, I clearly sum across the column of 0%. But what is the joint probability? How do I observe the joint probability of x1 being equal to 0% and x2 equal to negative 1? So can you tell me what is the probability, joint probability that x1 equal to 0% and x2 equal to negative 1 from the table? Obviously, how much? From the table. Correct. It's 9%, right? We are talking about this, guys, this entry. This entry. Now is it okay? See this and this. Is it okay now? 9%? Okay. Now, if I want to find out the product of marginals, PA times PB, okay, where A is x1 equal to 0%, let's say. Let's say we define the event A as x1 equal to 0% and we define the event B as x2 equal to negative 1. Okay, so what is the product of their marginals? The product of their marginals is this 30% times 30%. This is also 9%. Agreed? Is it clear? So can you tell me, does this hold true for every single cell? Just at random, check 3 or 4 cells at random and tell me, is it holding true for most of this or all the cells? Not most. For every single cell. Okay. Okay, Abhishek, these discussions we can have on private chat. Whenever I give a question separately, I will mention private chat. Sorry, these discussions we can have in public chat. Sorry, Abhishek. Okay. So that we can access easily. Because now what Zoom has done, it has created tabs actually. That is why. So I have to go to a separate tab for your private chat. Okay. So for every single cell, this is completely same. The joint is equal to the product of marginals, and that is why in this case with these numbers, these two events are independent of each other. Okay, so just the numbers have been tweaked a little just to make this example clear. Now see why I said GARP has done it beautifully, because see, we have to make sure of a lot of things. Every single cell should be satisfied. That is the first condition. Then the sum across all the columns and rows, the final row and final column has to be 100%. So those two conditions have to be maintained. So, you have to be clever in choosing your numbers. Even if a single cell was violated, these two events would not have been independent. So if you go to the original example, were they independent? Let's go to the original example. Yeah, this one. Are they independent? By any chance? Just multiply the marginals. You will not find that they are equal to the joint. In this case, they are not independent actually. Okay. So the numbers have been tweaked just for this particular example for you to understand the idea behind independence for probability matrix kind of table. Okay. Fine. Now, if you remember from first chapter probability, equality of the conditional and marginal PMF was a requirement of independence. Do you remember that we discussed this, that conditional probability makes sense only for dependent events, because if the events are independent, then conditional probability will be same as the unconditional probability. Do you remember this? Okay. So in this case, we'll write conditional probability is same as the marginal probability. So marginal probability or unconditional probability, whatever you can call it. In this chapter, we are using the word marginal. Okay. So the idea is same. So in the previous example, you can check. In this example, not this one where numbers were tweaked. In this example, let's say if I don't want to check by multiplying, okay, we just want to check by comparing conditional and marginal. So these are the marginals 35, 30, 35, then 30, 40, 30. And this was the conditional distribution 25, 37.5, 37.5. So very clearly, marginal is something else. Conditional on x2 being equal to 0 were three different numbers, right? These three are not same as these three. So the events are, the components are not independent. Okay. Now expected value, again the same idea. This is the formula. Again, I will strongly recommend don't remember this at all. Not required.
Sir, you said it's not independent, or is it independent?
No, not independent because these numbers are not the same. Nitin, as I mentioned, we are not talking about this example. So we have to very this example. We are not talking about this example. Okay, we are talking about the first example. In this example, they were independent. But if you look at the first example, we verified by checking if you multiply these two, are you getting the joint? No. You multiply 35 and 40. 35% times 40%. Are you
Mhm.
getting 10%?
No.
No. So obviously they are not independent. Correct. But instead of the multiplication method, if I want to verify using this method, Nitin, okay? If I just want to verify using this method, I will just compare the two distributions and I will see if the numbers are same or not. If they are not same,
They
then
are not independent.
clear?
Okay.
Okay. So they are not independent. Not independent. I'll write it once again for clarity. Not independent. Whereas in the previous case, the example that we constructed specifically, these are independent.
Mhm.
With these numbers, they are independent. But with the original numbers, they were not independent, which is verified both from the multiplication as well as from the comparison between the conditional table and unconditional table. Okay. So for expectations, don't remember this formula. Just remember the same formula, summation pi xi. That's it. Okay. Now, of course, just like the univariate case, expected value of g is not equal to g of expected value for nonlinear function of g, any nonlinear function. Now, again, this is exactly the same as this. E fx is not equal to f of ex. Do you remember any example? We did two examples actually in the previous chapter. Second and third chapter both, in fact. We studied the examples. Anyone who remembers any example?
Throw of dice, I think.
No, 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 no. F where f is a non-linear function.
Oh, okay.
We call this. In fact, we repeated this in the variance calculation also, variance calculation formula. We took a function x square, remember? And we discussed that e of x square is not equal to ex whole square. Now you remember,
Yeah, yeah.
right? Similarly, another example we took 1 over x. E of 1 over x is not equal to 1 over ex. And this is true for non-linear functions. These are non-linear functions. But for linear functions, they will be equal. Okay. Only for non-linear functions, they are not equal. Okay. So let's solve a question, very simple one. So these are the four probabilities that are given, joint probabilities. Expectation of x1 being equal to 1 and x2 being equal to 3 is 15%. Okay. So just like that, all the four numbers are given. This is the function, another function, x1 raised to the power x2. x1 raised to the power x2. So with x1 raised to the power x2, there are four possible outcomes, of course. 2 for x1 and 2 for x2. Okay, two outcomes for x1, two outcomes for x2, which gives us four total possible outcomes because 2 times 2 is 4. These are the four outcomes. You have x1 as the base and x2 as the this power or exponent. Okay, so 1 raised to the power 3, 2 raised to the power 3, or 1 raised to the power 4 and 2 raised to the power 4. Why you cannot have 4 raised to the power 2 as any outcome? Because 4 raised to the power 2 is not defined, right? As per the function. X2 has to be in the power, not in the base. Okay. And 4 is x2, not x1. That is why. So is it clear? The four outcomes are clear, right? So tell me, if I want to find out the expected value of g x1 x2, what will I do? I'll multiply these joint probabilities to the outcomes. Okay, so joint probabilities to the joint outcomes, I'm just multiplying. Can you tell me what will be the answer quickly? Send the answers via private chat. Send the answers via private chat quickly. So only we have what we have done. We have just simply multiplied all the probabilities by their outcomes and we have added them. Got it? How much we are getting? Shiva, check again. Hashima, check again. The numbers are not that large for such a big answer. 2 to the power 4 is 16. 1 to the power 4 is 1. 2 to the power 3 is 8, right? So, got it, got it. Abhishek, correct. Shiva, correct. Now, yes, Srija is replying on the main chat. Fine, it's correct, Srija. So, you'll get 3.95. Okay. And Aviyank, again, some numbers probably are flipped. Just check again. Nitin, just check again. Okay. Punch correct. Ashima correct. Ujjwal correct. Fine. So it's 3.95. Okay. Now we have seen moments, right? Moments in case of univariate. So moments in case of multivariate also will be the same, only the representation is different. Now this time they are just components. Okay. Yes, actually, yes. Absolutely, yes. You have to use bottom because multiplication will come first and then you have to add them. Correct. Nitin. And that is why you need to be very careful why you should keep the, how to operate the calculator. Because by default, I always advise the candidates to use the chain mode instead of the AOS mode. There are two modes in the calculator actually. You have the AOS mode which follows bod mass and you have the chain mode which does not follow mod mass. And I ask you to use the chain mode. Okay, so if these kind of questions are asked, the calculations, and I've given a very detailed reasoning also in one of the questions which was asked in the LMS that why we should use the chain mode. In fact, in the video I've said chain mode, the calculator video, I've given a very detailed reasoning also. In spite of the fact that chain mode does not follow mod mass, for the exam, chain mode should be the natural choice for you. Again, it's your choice. That's my recommendation because many people might be more comfortable with having the default BODMAS mode set. So for them, I think it's okay. But sometimes, trust me, I mean, if you see the percentage of silly mistakes using the calculator in the exam, there is a higher probability of having an error using the AOS mode. I mean, and this you may find a bit ironic when I'm saying this because when the calculator is following BODMAS, these calculations will be more straightforward, right? But it's not only about these calculations. There are multiple. It's not a scientific calculator, right? It's a financial calculator. There are a lot of things where chain mode will be more natural and easy to handle. So we were having these moments, and in the case of bivariate, again you have two components for the mean moment also. Okay. Now, if you remember for univariate, we had variance, the measure of dispersion. In this case, we have covariance between two components. It is actually the measure of co-movement. Okay, and this formula is analogous. The first formula is analogous to this formula of variance. The second formula is analogous to this formula for variance. Again, analogous. These are not same. Analogous, not same. Okay. And just like variance, where I told that we should prefer this version of the formula for more efficiency if the probabilities are not same. Because if the probabilities are same, you can directly use the financial calculator data and stat buttons. But if the probabilities are not same, I prefer using the second version of the formula. For covariance also, I use this formula. I prefer using this formula for speed and efficiency in the exam. Okay. Now in bivariate random variable, if you remember, sorry, in univariate random variable, if you remember, there was only one variance. A single variance is there. Of course, there will be one variance for one variable. In this case, there will be two variances, of course, because there are two components. You can find the variances separately. But you also have one covariance. So total, you have these three measures. You can have variance of x1, you can have variance of x2. You can have covariance between x1 and x2, and these are the representations. This is how they are represented. Okay, sigma 1 square or sigma 1 1. This can be represented as sigma 1 2 or sigma 2 1. Then what is correlation? We have defined covariance. Now we want to see why do we need correlation? Even though we have covariance, why do we even need correlation? Because see, if you remember when we were talking about third central moment, was the third center, what was the third central moment? And I'm sure I'll get wrong answers over here from probably almost all of you, but still go ahead. Even with my borrowing, go ahead. What is the third central moment? Okay, Ujjwala said skewness, Abhishek skewness. Okay, what about others? Skewness. So everyone will say skewness, right? And by default, I've already told that it is the wrong answer. No, not mode. Actually, skewness is not the third.
Asymmetry.
Sorry, sorry.
Asymmetry.
What did you say, Nitin?
Asymmetry.
No, 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 no. Actually, it's about skewness only, but it's not the third central. Skewness. Skewness. Why I said everybody will say wrong? Because skewness is the third standardized central moment. If you divide by sigma cube, then you are getting skewness. Do you remember now? The third central moment was actually the numerator of skewness. Do you remember now? The formula? Okay. We had expected value of x minus mu whole cube divided by sigma cube. We were dividing it by sigma cube. Correct. So we had to standardize it. Okay, because what was the reason I told? I told that because ex minus mu whole cube becomes a very, very large number and it becomes difficult to handle and interpret also. So in this case, that is one of the reasons why we are standardizing covariance to get correlation. That is one of the reasons. First, we'll see how we are doing it. we are dividing the covariance by the product of the individual standard deviations. We are dividing the covariance by the product of the individual standard deviations. How we are doing it, it's clear. So what does correlation do? Correlation measures the strength of the linear relationship between two variables and is always between -1 and +1. That is the benefit of standardization. By dividing it by something, in this case, product of standard deviations, we are actually making it more accessible, more easy to compare, and more meaningful. Okay, so before we move forward, I just want to remind you that since we get correlation is equal to rho 1 2 is equal to sigma 1 2 by sigma 1 times sigma 2. So vice versa is also true. Of course, you can also calculate covariance from correlation. So instead of dividing, you just multiply by the product of standard. So you're just taking these two on the left side. That's it, nothing else. Okay. Now, why this is important? Because covariance only gives you the direction of co-movement. It does not give you the strength of the relationship. Okay, so what do I mean when I say this? Suppose covariance between A and B is equal to 564 and covariance between another set of variables P and Q is 27. Both the covariances are positive. So both the covariances tell us that these two pairs in both cases move together. A and B also move together in the same direction. P and Q also move together in the same direction because the sign of covariance is positive in both cases. Plus 564 and plus 27. Right? Plus 564. So that plus is important. Sign. But the magnitude of covariance 564 and 27, they don't tell anything about the strength of this relationship. It means that A and B are moving more strongly with respect to each other as compared to P or Q. That is not expressed explicitly by the value of covariance. So the value in itself does not carry much significance. But if I tell correlation between A and B is say 0.2 and correlation between P and Q is say 0.35, then it is very clear that of course direction is positive for both. Both A and B are moving in the same direction. Also P and Q are moving in the same direction on an average together. But it is also telling that P and Q are more tightly bound because of their higher correlation as compared to A. A and B are loosely bound. The strength of the relationship is higher in case of P and Q. Is the idea clear? Why do we use correlation?
Yeah.
Okay. Now, in the last class, you might remember that we transformed the variables, linear transformation, and we saw what effect that transformation has on different moments. So, in this case, we will see what effect the transformation on the two components has on the covariance. So, again, we are taking linear transformations in both cases. For x1, we are transforming it into a plus bx1. X2 we are transforming it into C plus dx2, and we will see it can be quite easily proved that this part, the additive part, will not make much difference, so it will be gone. The multiplicative part, these two will come out of the bracket, and it will simply be covariance between x1 and x2. Okay, so for example, if I have covariance between 7 plus 3x1 and 5 minus 2x2, so this 7 and this 5 are non-existent on the right side. You cannot see them on the right side. So it's 3b times d, d is -2 times covariance between x1 and x2, which becomes -6 times covariance between x1 and x2. Okay. Now with respect to correlation, A and C of course will be gone. There is no doubt about that. But in terms of B and D also, their magnitude will be gone, only their sign will remain. So A and C again gone, B and D not completely gone, magnitudes gone, but signs of B and D still remain. Okay, so let's see an example. It is given row x1, x2 is equal to negative 0.78. Okay, so if I have to find out row 8 plus 3x1, comma 2 minus 4x2, can you tell me what will be the answer? I've also given you a hint in the second step. This is quite straightforward. Quite straightforward.
Plus 0.78.
Correct. Plus 0.78 because sine of 3 is of course positive. Sine of negative 4 is negative and correlation was also negative. So positive, negative and negative which gives us positive. So 0.78. Okay. Similarly, if I want to find out this, it will again be 0.78. Okay. So no problem over here. Now, what are the properties of covariance? These are the properties. Just like we had properties of variance and expectations, we have properties of covariance also. If two variables are independent, then of course there will be no co-movement between them. The covariance will be equal to 0 without any doubt. Now just think about it. Before I move on to the second property, I want you guys to derive the second property or deduce it from this analogy that we were drawing and from the formula of covariance. Now, if I ask you what is the covariance of x1 with respect to x1? So basically, instead of x2, you have to substitute x1 only. So can you tell me what will you get? Just
Variance of x1.
very good, very good. It's very clear that covariance of any variable with respect to itself is the variance of that variable. Okay, mathematically it can be clearly seen. Now covariance between a plus bx1, this we have already seen earlier. The variance between variance of x1 plus x2 is this, and variance of x1 minus x2 is this. Okay. So obviously, if you have independent variable, let's say x1 and x2 are independent, then the covariance term will disappear, of course, without any doubt. So whether it is x1 plus x2 or whether it is x1 minus x2, the variance of both will be same, vx1 plus vx2, because this term was the one creating the difference, plus 2 covariance minus 2 covariance. Okay. And finally, ax1 plus bx2, variance of that is equal to a square variance of x1 plus b square variance of x2. Now, one thing is important, even if you add constants, let's say a x1 plus c plus b x1 plus d, just like that, a plus b x1 plus c plus d. So these additive terms won't make any difference. Just remember that in case of variance and covariance. Okay. So this is the general formula, general property, the last one that you can remember. You should remember actually. So again, if you remember the formula of a plus b whole square, you can draw an analogy there also. Again, analogy, not same. Okay. These are just analogies. Now, how do we represent a covariance matrix, which you will encounter so much in part 2? In part 2, most of the calculations in market risk with respect to the VAR and even more calculations in investment management with respect to VAR, particularly VAR, are done using the matrix method. Covariance matrix will be involved. Okay, yeah. Pooja, you were saying something?
I'm sorry to interrupt. If you can just show that slide, the properties of covariance, just one more time. I just wanted to make sure I've noted down everything.
Yeah, yeah, sure. Please, please. Please go ahead. Self notes is always a good idea. See, this is actually I'll say a very sincere,
Sir,
even though you know that these slides will be shared with you. If still you
hello.
have your own notes, that's very good. Yes, please go ahead, Parth.
Sir, I had a query. Like, we get a PDF after watching the recorded lectures. No, there is a PDF of that lectures,
Correct.
and I think so. After the live lectures as well, we get a PDF, right?
Correct.
So,
Correct.
which one should we like use for making notes like
For the first round, you should use the main PDFs, the ones after the video.
hmm.
Okay. And then during your revision, you should use this PDF.
No. For making handwritten notes, because that
The second
PDF
one.
is a bit
The second
lengthy.
one. The second one.
So the second one, the content is enough, no?
The content is enough for handwritten notes.
Okay.
Absolutely.
Okay. And
Okay. Okay. Yeah. And Pooja, you don't need to say that sorry to interrupt and all. Okay. Anytime you can stop me and say whatever you want. Okay. Don't worry.
Okay, thank you.
Because it's your class. Okay. I'm the instructor. The class is yours. Okay. Now let's come to covariance matrix. So if you have two components x1 and x2, this is how it is represented. So covariance between x1 and x1 is of course the variance of x1. That's why we have written it as sigma 1 and x1 is implied. Okay. When I write sigma 1 square, I'm talking about x1 only. So sigma 1 square. Similarly, covariance between x2 and x2, sigma 2 square. Okay. So and these are the covariances between x1 and x2, these two. Sigma 1, 2 and sigma 2, 1, which will be same. So these two are same. Total three parameters are there in this. The diagonal, the principal, see there are two diagonals. But the principal diagonal always represents this diagonal, always represents the variances. Always. It represents variances. Now let us come to the interpretation of correlation. Okay. Now correlation coefficient is given, the range of correlation coefficient is given over here. And the interpretation is given over here. And this chapter we'll see something very interesting also, which I have discussed in the video also. But I'll go into a little bit more detail over here in this chapter in the class because it is a bit ignored. Okay. And it is important, I think. So correlation coefficient, if it is -1, it is a perfect negative relationship. Perfect. Between -1 to 0, a negative linear relationship. If rho is 0, no linear relationship. Okay. And in this case, positive linear relationship. In this case, perfect positive relationship. Okay. Now, if rho is equal to 0, since there is no linear relationship, you can also say that this is a case where the two events or the two components are independent of each other. Now, so I'll just show you the cases. Suppose first case, you have a very tight correlation. You can see that the dots, and mind you, this figure actually is an extract from the Excel only, where actual data was plotted from our side, and these correlation numbers have been derived from there only. Okay, so this is actually a very accurate representation of rho equal to 0.9. Very, very tight. But what if we have a low correlation? Positive one, but low. So the line is still going up, but it's quite loose, right? The points are quite scattered here and there. Similarly, a very tight negative relationship will look like this, 0.92 negative. And a loose negative relationship will look like this, loose one. Okay. What about perfect linear relationship or perfect correlation? All the points will be exactly on the line. And for perfect negative correlation, again, all the points will be exactly on the line, but towards the southeast direction or northwest direction. So from northwest to southeast or vice versa. Okay, it's completely, I'll say, insignificant, or the direction as far as interpretation of correlation is concerned. Direction does not matter. From northwest to southeast or from southeast to northwest. Okay. Now,
hello.
yes.
So, sir, while plotting these points, by default, do we always take them in the first quadrant?
No, actually, it will depend on the data set. Let's say you have the data set on the negative side also. For example, you can take a practical example. Let's say you are plotting, I mean, although they might not be a direct relationship, But let's say you are instead of returns, you are trying to see how the prices of two stocks move, or for let me forget the prices. Let's say one stock and the index. Okay, so you just want to plot that how the price of TCS is affected by the index level. Let's say Nifty. Okay, for international candidates, I just want to tell you guys that Nifty is the index which is managed by the National Stock Exchange through another intermediary actually. And Sensex is another index in India which is managed by the Bombay Stock Exchange but directly. Okay. So I'm just taking an example of Nifty. Nifty here means index. Okay. For international candidates, I'm saying. And TCS is, of course, one of the companies in India. So if I want to plot the relationship between TCS and Nifty, we expect a positive relationship, of course, but since we are talking about prices only, is it possible practically? Even theoretically, it's not possible. Practically, though, it will not even go to zero. But is it possible, both practically and theoretically, that the stock price or index level can go negative? Is it possible, Parth? Anyone can answer. It's okay, open
Sir,
to.
I don't have idea about these terminologies.
Okay, but you can at least make sure na, that see the price of any stock, can it go negative for any stock? Think about it.
No.
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 So yeah, price of TCS also cannot go negative. So index also Nifty. If you see Sensex or index, have you ever heard that okay Sensex has gone negative? You will generally not hear. Okay, totally understandable if you don't have idea. You are, let's say you don't have a financial background. Completely okay. It won't make a difference towards your FRM preparation. Trust me, very little difference. Very little difference. Just have to be very sincere. Okay, make sure that whatever jargons you are hearing for the first time, do some research. Now very healthy practice for such candidates like you. It will not only help you from the class perspective but also from your knowledge perspective. Now when you are revising this chapter today, you should, the words which I use which you are not familiar with, okay, Nifty, just do some research, see some data, what is the index, you will get good insights. Okay, see some news, latest news, and maybe gradually after 5 years you will also start investing directly, okay, managing your own portfolio of equities. Okay, so these things will give you knowledge, and as I said, don't worry if you don't understand these terms initially. It won't make much difference in the preparation. Okay, so the price as well as the index level, the price of the stock and the index level, they cannot be negative, both of them. So obviously, Parth, since both of them cannot be negative, so the entire graph will be on the first quadrant only. Correct, Parth? Because
Yes.
both variables are positive, right? That is why. But if you analyze the returns, for example, let's say if I want to be very, very granular means I want to make it more at a micro level. Okay, I don't want to plot annual returns versus annual returns, because in a long run, annual returns for index and annual returns for a stock, it's very rare to find out annual returns of good stocks being very rare. It can happen, but very rare, or unless and until we are in acute recession. In normal circumstances, let's go for daily returns. Daily returns, of course, maybe out of the 5 trading days in a week, maybe 2 days you will have negative returns. It is possible. So if I plot the daily returns of TCS versus the daily returns of Sensex or Nifty, since both of them can take negative values path, so is it necessary that they will be in the first quadrant?
No.
No. They can be in any
Third.
of the quadrants, preferably first and third. Preferably first and third. But there will be days where it is possible. In fact, it is such a good question that you have asked, that we can address anomalies also over here. So I will just draw this diagram for you, where we have some space, boss, not in this slide. Yeah, in this slide. So I said that when we are plotting price versus price, okay, so we want Nifty index level. Okay, so Nifty 50, and we have TCS, and these are prices. Okay. So obviously most of the points, and I'm just assume that this is starting from 3000 or whatever the level is. I'm not worried about that right now. Okay. So don't worry about the initial level where maybe somewhere over here. So these are the points maybe. Okay. Okay. So yeah, it is possible that we get a graph, and of course, it is almost certain that it is going to be in the first. In fact, almost yeah, it will be certain that it is in the first quadrant only. But if we plot returns, daily returns, TCS daily returns. There's some lag in the pen, guys. Okay, so I'm also having some problem in writing. And let's say Nifty daily returns. Okay, so we have this, and yeah, there will be days where some both of them will be positive most of the days, maybe 60% of the days, but there will be say 30% of the days where both of them will be negative. So first and third quadrant maybe slopes might be different. Maybe slope is different over here, slope is different over here. Two lines you may get. But in this case, it is also possible that in the rare cases, some of the times TCS returns will be positive, whereas Nifty is negative. Very rare. Maybe see again, we can go for practical ideas why it is possible, and in case of TCS particularly, why it can be possible. Because see, TCS is a company which is not only exposed to India. TCS is having exposure all across the world and a big exposure in the US, right? So again, I'm constructing a very hypothetical scenario for this case. So let us assume there was a day where it was not very good for overall for Indian economy. Some institutional investors, they left the scene, and there was heavy disinvestment or something like that happened, and the market got very badly affected, and the Sensex went down, the whole market went down, but at the same time, rupee also went down. So overall, it was very bad for India. And say TCS's results were about to be announced, and it was expected that TCS has generated massive revenues, and the revenue growth has been say 50% or 40% or even 10% in its say it's a US based business. Okay. So since TCS is this rupee has depreciated very badly, and TCS is going to receive its revenue in dollars, more revenue in dollars. So even though TCS will be negatively affected by Indian market, definitely, because it's the part of the broader market, it will be negatively affected. So that part will take TCS down, the Indian part. But because of the depreciation of the rupee, TCS, since it has a very big exposure to the US business, and it is about to receive a lot of dollars, its dollar revenues are going to increase massively. So in terms of rupees, think about it. In terms of rupees, if we talk about, since maybe the contract terms have not changed. The contract terms are that okay, in the revenue part earlier it was $90 million, and the contract term was that okay, after maybe 1 year when the service is given, it is about to receive say $100 million. And again, these are hypothetical numbers, guys. The number will be actually much higher for such kind of relationship to hold true. But let's say it's about to receive $100 million. Since the rupee has depreciated, guys, it means dollar has appreciated. And if dollar is appreciated for the same number of dollars, for $100 million, the contract has not changed, it's still of $100 million. For the same number of $100 million, will TCS get higher number of rupees or lower number of rupees, lower amount? Higher amount?
Higher.
Exactly, higher amount of rupees, right? Because rupee has depreciated and dollar has appreciated. Say earlier, rupee was 85 per dollar. So 85 rupees was equal to $1. Now, after this crash, this Indian market crash, suddenly say rupee has become 100 rupees per dollar. So earlier, TCS, which was supposed to receive $100 million, so based on 85, if you calculate based on 85, it will be 8.5 billion rupees. right? $100 billion times 85 will be 8.5 billion rupees. Okay, now it has suddenly changed to 10 billion rupees. Okay, so that part will benefit TCS or not? Agreed? It is possible? Even if the answer is obvious, a simple yes or no would be very helpful for the making the class interactive.
Yes.
Okay, so in those cases, it is possible that we will get maybe the returns of TCS as positive, whereas the returns of Sensex being negative. So it can be in the second quadrant also. So most of the points will be in the first and the third quadrant, but some of the points can also be in the second and fourth quadrant. Okay. So see these questions, I mean, so nicely we are able to discuss some practical examples because such questions are asked. That's why I say don't hesitate in asking questions. Questions are important. Okay. So clear path now, quadrants and all.
Yes, sir.
Okay. So as I said, one of the parts which I want to have pay a little bit more attention on in the video, which should have been given in more detail in different textbooks, including GARP. In fact, a very little comparison is there. But this comparison makes a lot of sense because when we talk about correlation and we compare it with slope, in these two cases, whose slope is higher? First one or second one?
Second one.
Second one, of course, is steeper. So it's higher slope. So the first one slope is 0.3, again, actual data. Second one slope is 0.75. Okay, what about correlation? Whose correlation is higher?
Same.
Exactly. Correlation is not higher for second one. Correlation is same for the first as well as the second. And it can be clearly seen that in both cases the correlation is 1. Why I am so confident that it is 1?
It's on the exact same line. Yeah.
Exactly. Because correlation being equal to 1 automatically implies that the points are on the line. So the condition for correlation being equal to 1 is that all the points should be exactly on the straight line. The slope of the line does not matter. The slope of that line does not matter. Okay. Next. Okay,
So
now this is
even,
a precursor. Any question, Nitin?
yeah, so even the distribution between the points is also not kind of, so between point 1 to point 2 there is a equal distribution as I can see. So is that also one of the
No, no,
things?
no, no, no. That is not. Even if suppose it is not equal, let's say Nitin, we have, because see we have data points uniformly distributed. This is
Yeah,
the example that we took. Even if we did not take this example, let's say it's a very good question again, I'll say. Let's say if the distribution was not very uniform, if suppose we had one point over here, okay,
but
the
still
other
on the
point
same line.
over here, third over here, fourth over here, like this.
Yeah, yeah.
Okay, even this is rho equal to 1. So the distribution, uniformity, dispersion does not matter unless and until all the points are on the line with it. Good question. Got it?
Yep.
Okay, great. Now this is a precursor. This and they have included this in quants, and I think it's actually good that they have included it. This is actually a precursor to some of the formulas that are important from the point of view of chapter number 5 of Foundations of Risk Management and also VAR, book 4, first 2 3 chapters. Unfortunately, I'll say after 2020, they have actually removed this portion from chapter number 5, but it is still retained in VAR, this formula. But I think this should have been taught in modern portfolio theory also. Okay. So there is an extra lecture also given in the LMS. If you want, you can go through that lecture for FRM5, not for this chapter. For this chapter, though, we are covering it, whatever is required. We are not covering detail because it has been just been introduced. In VAR, we'll cover it this in detail. Okay. So the idea is that if there are two assets A and B, only two assets, and if you want to construct a portfolio, the portfolio is constructed in such a way that the weight of asset 1 in that portfolio is W1, and by default the weight of the second asset has to be 1 minus W1, which we are denoting it as W2. Returns are given R1 and R2, capital R1 and capital R2 of the two assets. Variances of the two assets are also given, sigma 1 square and sigma 1 2 square. These are all given. Correlation again given. So if this data set is given to you regarding the variances and returns of the two assets along with their correlation, then two parameters you can easily estimate. You can estimate the estimated return of the portfolio, which is simply the weighted average returns. W1 ER1 plus W2 ER2. Simple. And the formula for variance is W1 square sigma 1 square plus W2 square sigma 2 square plus 2 times W1 W2 sigma 1 sigma 1 2. Sigma 1 2 is nothing but the covariance. So this sigma 1 2 is same as rho 1 2 times sigma 1 sigma 2 as we saw earlier. This part is nothing but the covariance. This is exactly what we saw earlier in the formula of covariance. This is the formula of covariance only. Okay, this formula you have to remember by heart. Derivation is
Sir,
straightforward. Yes, Parth.
can you elaborate a bit on the concept of weight?
Yes, I can. Wait, we'll discuss in great detail in Foundations of Risk Management portfolio, but I'll just
Okay.
elaborate over here. Okay, a little bit I'll tell you. Okay, so if suppose you choose that, okay, I want to build, what is your age right now? But if you don't mind, of course.
27.
27. So you have a very long term for investing, and you can take more risk as compared to, say, a 60-year-old person who has to mainly invest their funds in liquid instruments, but you can go for more risky assets. Okay, as far as your investment portfolio is concerned, based on your age. Okay, and of course other requirements will also be there, but as of now I'm only considering one variable age. I'm not considering any other variable. Generally, if anyone wants to build their portfolio right now, they should go and try and go for some risky assets. So let's say you decide in a very simplistic scenario, you decide that, okay, I only want to invest in one mutual fund, and along with that I want to invest in only one government bond. Okay, now mutual funds, you analyze, you check. You don't want to take very high risk also. You want to see, okay, uh, the volatility of that fund. You give yourself a target that, okay, whatever fund I choose, I will make sure that the volatility of that fund in terms of standard deviation is not more than 20%. Okay, so you analyze all the funds, you see their volatility protection, downside protection, and you decide that, okay, I have found a fund whose return is CAGR compounded. Generally, when we talk about mutual fund, the uh, return measure that is generally preferred across the market is CAGR, compounded annual growth rate. Okay, so you see that, okay, this is a fund which is giving me a compounded annual growth rate of 15% and the volatility of only 19%. So yeah, this is decent enough. I'll go for that. So you invest in that fund, and the other thing that you want to invest in is government bonds. Okay, so you choose a 10-year bond, 10-year government bond. It is fetching a return of, let's say, 7% or something like that, or 6%. So you choose to invest in that. Now, if you want to take higher risk, Parth, then you will have more weight in the mutual fund and less weight in the bond. Okay, so for example, if you have 1 lakh rupees today for investing, international candidates, 1 lakh rupees is zero point 0.1 million. Okay, so let me say 10 lakh rupees so that it will be clear. So 10 lakh rupees means 1 million rupees. Okay, so he has 1 million rupees and you want to allocate, you want to take higher risk. So maybe you go for uh, 80% of your money you park in this mutual fund and 20% of your money you park in government bonds. So this, that is a higher risk side. So the weight is 80%. It means 8 lakh rupees or 800,000 rupees you have purchased this mutual fund, and 2 lakh rupees or 200,000 rupees you have parked in government bonds. But if you want to take less risk, Okay. Maybe you invest only 60% of your money. So 60% will be the weight. If you have 600,000 or 6 lakh rupees in mutual funds, then the weight in mutual funds will be 60%. Is it clear, Parth?
Yes, sir.
I guess clear. Okay, by the way, yesterday we had the fourth Financial Talent Summit in Bangalore. I was there actually at Taj, MG Road, Bangalore, those who are aware of the location. And it was organized by the CFA Society. Okay. And it was a very, I'll say, quite insightful event. There were company presentations from three different companies, startups, and there were company presentations from two established companies also. One of them was DSP, and the other one was London Stock Exchange Group. Okay. So these two presentations were quite insightful. Along with that, we had three startups. Uh, I think it was Tradomate, Multiple, and one Aon. I think Aon Consulting. Yeah. And then we had in the morning I was not available because of some classes, so I reached late. But in the morning also I heard that there were some insightful sessions based on some kind of AI and evolution of financial business in the future, careers and all those things. So I was not aware that even the candidates who were not members of the society were also there. So just for you all, I am telling those who are based in Bangalore or Mumbai, just try and attend such kind of events if possible. Another event is going to be organized in Mumbai very soon. Okay, so you can just check the CFA India page and you can see if such kind of events are organized. I would definitely ask you guys uh, to attend these kind of events because you never know. See, we had Tradomate and we had this multiple. They directly, in fact, they pitched for hiring. They got a lot of resumes from candidates. Students from Christ University were also there, and they were able to submit their resume. They were able to interact with the employers. So I think it was a fruitful session. And very soon we are going to have such session in Mumbai again. And in Bangalore, also, I think another session is planned in the next 2 months only. In Mumbai, it's very regular. Okay, so please do attend such
Okay.
sessions in Mumbai. Yeah, it will
Mumbai,
be
any
very regular.
specific location?
Mumbai, it's I think in BKC mainly, but all across Mumbai it's happening.
Okay.
Okay, in BKC, I think if I'm not wrong, I mean, CFA Society has its office also in Mumbai only, in BKC only. So it's very active over there. Okay, if you need any kind of reference or any kind of help, you can
Hmm.
directly ask me, and I'll make sure that if there is any kind of hurdle or if you're not able to register or any kind of issues happen, I'll make sure you are able to register and you have a fruitful session. So any kind of help you need from my side, let me know. Okay, but you have to do some research that when it is happening, and then you
Hmm.
can just message Philip on WhatsApp, and you can. Yes, that is for CFA, but even candidates who are preparing for FRM can go. No problem. See, yesterday one of the companies, Tradomate.one, they were actually presenting. They, although they mentioned that CFA candidates will be preferred, but I think if you are an FRM candidate and you are interested in becoming a researcher for them, then I think it's good. Yeah, it's relevant, definitely relevant. See, even if it's
So
for
is it like a
CFA,
job
Abhiyang,
fair or something?
yeah,
Or maybe
yes,
internship?
yeah, they were offering full-time jobs actually.
Okay.
Okay, Abhiyang, yes. See, if there is a general discussion going on where you get to know the future of fintech services in this evolving AI world, it's definitely relevant for FRM candidates also. Definitely. Okay, so make sure you go there. Some kind of, and I used to email a lot to GARP. In 2017, we got this authorized training providership with GARP. We were the first one in India, and I used to email them a lot that we should be very active and we should also try and organize events like CFS Society is doing a lot of events, but as of now, they are not very active. Even their Mumbai chapter is not very active. And yeah, Abhyank, it's not very active, Abhyank. I think in Delhi, there are some people who are involved a bit, but not that much. CFA Society is much more active. And it's 100% relevant for FRM. No problem in that. Okay. you will definitely gain some insight. You never know. There might be an employer who might be hiring for risk. Right. I mean, in fact, they were making a presentation, Tradomate, and they were talking a lot about backtesting. You will not have an idea right now about backtesting. But there were many natural questions which were coming to my mind, although they were not able to answer because there was the lack of time. So they did not have a Q&A session. So I had a lot of questions in my mind that, they are talking about backtesting and see, talking about backtesting is easy. Building your models is very easy and then backtesting them there. But when you want to build a very good sound model, you need to make sure that even pre back testing things, which I'm very sure that modern trading platforms completely ignore. In fact, trading platforms never had even back testing earlier, but nowadays at least some of them are having back testing. But it should be more, I think, comprehensive pre back testing. The testing of the conceptual soundness of the models should be the first priority. And then post back testing, are you validating your model? What is the benchmark? So all these questions were not addressed, have not been addressed in their models. So I just gave them a suggestion and they were quite happy. And I think uh, in terms of the relevance of those events for FRM candidates, I'll say that for FRM candidates, they are almost as relevant as CFA. Even for non-FRM or non-CFA candidates, even they should attend such events because you get a lot of insights, and networking opportunities are amazing. You get to connect with people. You never know what might happen in the future. Okay, so make sure that do some research, and you can always consult with me regarding the at least you can take a suggestion from me whether you should go or not. Okay. Yeah, from networking standpoint, it's really good. Okay, so these two formulas you have to remember by heart, this one and this one. Now this is a special case that has been represented in this diagram. Actually, W1 has been set to an optimal weight. W1, the weight in one of the assets, has been set to an optimal weight. How that weight has been calculated? Not in the course. Although using calculus, it is not very difficult. Okay. You can just minimize and set the first derivative to 0. You'll get the directly optimal weight as sigma 2 square minus sigma 1 2 divided by sigma 1 square minus 2 sigma 1 2 plus sigma 2 square. This is the optimal weight. What is the optimal weight? Optimal weight is the weight where, yes, we are just about to finish Nitin, and then we can have a break. Okay, don't worry. It's not, it will not take much time now. Okay, we'll take a break. So W star, the optimal weight is the weight where variance is minimum. And this is the formula you need to remember. You don't need to derive it. Okay. Now, the whole idea is that, see, what is happening? If you are decreasing the correlation, see, correlation is decreasing, standard deviation is also decreasing. So, with this optimal weight, it is possible to construct a portfolio with 0% standard deviation, almost a risk-free portfolio with a exactly negative one correlation. So that is the idea with this diagram, that as the correlation is decreasing, the standard deviation is going to 0%. But there is a huge issue if you see that how can the standard deviation go to 0% if the correlation is plus 1? Because if the correlation is plus 1, it means that both are moving together. Either both will move up or both will move down. So it's actually very high volatility portfolio. How is it possible that you can have 0% standard deviation with a very high correlation? Now, again, I want to give a very practical example over here. See, for this part, and then I'll come to this part. Suppose you have two stocks in your, again, very, very hypothetical examples I'm constructing so that everyone can understand. Okay. Suppose you have two stocks in your portfolio. One of the stocks is a, a, a copper producing company. Okay. Which produces copper and it sources its say mining activity from say Sri Lanka. It's an Indian company. Then there is another company which also say it does not produce copper. Let's say it produces say lead. Okay, industrial lead for say pencil or something like that. And it sources its mining say from Cuba. Okay. Since both of them are producing lead, is lead a metal? Anyone has any idea? Is lead a
Yes.
metal? Yes. And copper?
Yes.
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 So both are metals, both are metal producing companies. So what will you expect? A positive correlation it may not be high because maybe lead and copper move not much together. The demand supply is not that similar, but still there you can expect still a positive correlation. Both are producing metals to some extent. There might be maybe a small positive correlation, maybe zero point 0.2. Okay, but what if you have two stocks? One is a company which produces lead, okay, for pencils, and another is a pencil producing company itself. And again, this example is constructed in a very layman terms where other variables are kept constant, because other variables means what happens that if the price of lead reduces, automatically the price of pencil will also reduce. That is what happens. But we are not considering market forces at all. We are just considering that one company is using lead as input, the other company is producing lead as output. Okay. So, what do you think with the price of lead, if other things are held constant, with the price of lead, what kind of correlation you can expect? Because the company which is producing lead probably will benefit. See, its mining cost has not increased, but its selling cost has increased. So it means it is getting more profits. But the company which is using lead to produce pencils, say the prices of pencils have not changed in the market, but its input cost has gone. The price of raw materials has gone up. So it probably might see its profit margins shrinking a bit because of the increase in price of the lead. So one company is seeing margins increasing because of increase in price of lead. The other company is seeing its margins shrinking because of increase in price in lead. So based on that only, what do you think the correlation between them will be, positive or negative, between these two companies?
Negative.
Very good. They are moving in opposite directions, right? So the correlation seems to be fairly negative and decently negative, right? So hypothetically, you can see that as you are going on the negative side, so obviously, since you are going on the negative side, and if you have both stocks in your portfolio, then even if the price of lead increases, you are protected or not? Because if one of the company's prices are decreasing, if one of the company's returns are decreasing, the other one is increasing, correct? So you are protected or not? If you have both in your portfolio, are you protected against changing lead prices?
So basically, we are covering the losses with the profit of the
Correct,
others.
correct. So are you protected?
Yeah.
Correct, you are protected. So that is why your standard deviation is going down. Understood? That is why the volatility of the portfolio, because if one goes up, the other compensates. So the volatility is very low. The portfolio is not that volatile. So is the idea clear why portfolio standard deviation is going down when correlation becomes negative? Is the idea clear? Is the idea clear?
Yes.
Okay. Now, figuratively and practically, we have seen why it is clear. Mathematically, it is very easy to derive. See, mathematically, obviously, if this decreases, it becomes more and more negative. Obviously, sigma p square will decrease because you have an additive term over here. So the more it becomes negative, because all these terms are W1 is positive, W2 is positive right now, sigma 1, sigma 2 positive. So only this term can become negative. As of now, we'll see the other case also. So if only this becomes more and more negative, this entire thing decreases. So obviously variance decreases, volatility, standard deviation decreases. So mathematically it's quite easy to derive, but practically also we have seen that it can happen. Okay. Now, what about the other side, guys? How is it even possible that with a positive correlation, the standard deviation is decreasing? So this can only be explained in one way. This can only be explained in one way, that the weight of the other asset is actually negative. If two assets are having perfect positive correlation, then for the standard deviation to go down, there is only one explanation, that W itself is negative. How can weight be negative, you'll ask? How can the weight be negative, you'll ask? Now, again, I'll come to the example of Parth's portfolio. Now, let's say Parth is not satisfied with even 80% weight in the mutual fund. Parth wants to take even more risk. What can Parth do if Parth only has 10 lakh rupees and Parth wants to invest more and more in the mutual fund? Parth sees, okay, there's a lot of potential in the mutual fund. What can Parth do? What options he has? Think about it. Okay, I think I've got some answers in the main chat. Yeah. So, anyone who can explain what can Parth do if he wants to invest more and more money into the mutual fund, more than what he has? Say he invests 100%, he's still not satisfied. What can he do? Yes, correct, correct. Ujjwal Vansh, absolutely. He borrows. Okay. So when you actually buy the bond, you are lending money to the government. Okay, the government is paying you interest. Return, what return you get from bonds is basically about the coupons and interest from the bond, right? But in this case, instead of buying bonds, you actually borrow from the market. Maybe the opposite, selling bonds. Okay, although I'll not go to that in detail, selling bonds right now, but taking loan or borrowing is better for you right now in terms of how much you have covered. So the understanding level will be easier. So once you borrow and invest, so let's say Parth borrows at an interest rate very close to say 7%, which he was getting from the government bonds. He borrows at 7%, say 5 lakh rupees. Okay, and he invests that entire 5 lakh rupees again in the same mutual fund. So how much money total you are having, Parth, in the mutual fund now? 10 lakh of yours and 5 lakh from the market. So what's the total now?
15.
15 lakh rupees. But out of that 15 lakh, 5 lakh is not yours, correct?
Yeah.
So the weight of your assets, if you say there are two assets, okay, one is the mutual fund, the weight is 150% in mutual fund because you have invested 1.5 times of what you had. And the weight in the cash, in the money that you have borrowed, okay, at say the risk free, let's call it the risk free rate and let's call it the risk free asset. So the weight is negative 50% because you have not invested in that. You have actually borrowed it and you have to return it. Understood how weights can be negative now? Is it clear?
Yes.
Another way weights can be negative, and this can be related to, of course, those who have some kind of trading knowledge. I think most of you would know it. Most of you guys should be aware of short selling, right? Short selling.
Yeah.
Okay, that also can produce because if you see, if you're talking about short selling, you're not the owner, you have short sold it, right? So you have sold it. It means that if there are two companies, let's say one is you have bought TCS, but you have short sold Infosys. Both of them generally have a very high correlation, very tight correlation, positive 0.9. But since you have shorted Infosys and bought TCS, your correlation instead of being positive zero point 0.9, it becomes negative zero point 0.9. So is the idea clear? Okay, call and put we'll discuss later, and correlation actually it's not necessarily Avyank, although you are correct, absolutely correct, Avyank. But there can be instances where even for both the correlation can be positive sometimes. But you're right. Generally, it will be negative. Okay, so either you take loan at the risk-free rate, you borrow at the risk-free rate and invest in a mutual fund, you can have a negative weight, or you can short sell and you can have a negative weight. Okay, so this is the idea. Now, when now we'll do this part very quickly, it's almost over. Okay, so when two random variables are independent, they must have zero correlation. But if they have zero correlation, they are not. So vice versa is not true, guys. Why it is not true vice versa? Because correlation is a measure of only linear dependence. It is possible that they will have zero correlation. So it means they have zero linear dependence. But it does not mean that they cannot have any other kind of dependencies. They can have. So for example, let's say there are two variables. X1 is a normally distributed variable. Standard normal. Zero mean, variance 1. Standard normal. I hope everyone remembers this from the last class. And x2 is equal to x1 square. Not a linear relationship, square, quadratic relationship. If you calculate the covariance between x1 and x2, it is guaranteed, it can be derived that covariance will be 0. It's not a part of the course, but you can derive it. It will come out to be 0. But is there no relationship between x2 and x1? Of course they are related. x2 is equal to x1 square. So they are related. Got it? So linear relationship might not be there, but there can be some other kind of relationship. Okay, so covariance, we've already seen this is the covariance. Also, if the relation between the two variables is 0, the covariance of course is 0. So if you substitute 0 over here, if two variables are independent, if you substitute 0 over here, guys, will you get this? Will you get this? Correct? Expected value of x1 times x2 is equal to expected value of x1 times expected value of x2. Again, this is analogous to probability of x1 intersection x2 is equal to px1 times analogous, not same, analogous. Okay. Okay, now let's come to conditional expectations. Now, earlier I told you that to have the conditional expectation, you need to have a conditional distribution, not the regular distribution. So conditional expectation is an expectation when one random variable takes a specific value or falls into a defined range of values. It can take a specific value or it can take a defined range of values. So in the same example, the previous example that we have been doing, stock return, analyst rating, okay. So we have already found out, right, the conditional distribution. If you remember, given that x2 is equal to 0, what was the value of that, what was the probabilities that the stock return may take different values, negative 5%, 0%, or 5%. Do you remember this conditional distribution? These values 25, 37.5 and 37.5? Yes or no?
Yes.
Okay, great. So based on these probabilities, you simply now find out the conditional expectation. Very simple. These are the probabilities and these are the outcomes. So just do summation pi xi. So given x2 is equal to 0, these are the probabilities. The values are simply this pi xi. This multiplied by this plus this multiplied by this plus this multiplied by this. Finished. 0.00625 or 0.625%. Okay. So given that the analyst rating was neutral, the expected return on the stock is 0.625%. Finished. Okay, that is the idea. It's very simple. The only thing is that just we have to be very careful about the probability values that we are using. In this case, we will use the conditional probabilities from the conditional distribution. Now, what about conditional independence? You remember in chapter 1, we did a very beautiful example visually of conditional independence. Three sets were there. Okay, very beautifully we illustrated it. Over here, actually, it's a bit simpler. And I hope you all remember the visualization of conditional probability also. What was happening in the visualization? If I say PA given B, I'll just recall. And I just want you guys to just help me recall, and I'll see how many of you remember it. If I say P, A given B, which set becomes your new universe?
B.
Very good. So now everything will be conditioned on B because B has already happened. Okay. So this is the previous example now. Now what we do, we give a condition over here. We give a condition that we want to identify firms that have a conservative management style, and the style variable can be labeled as Z. So let's assume that only 12.5% of the companies are in the conservative categories, and the probability of outcomes and recommendations based on the management styles are given below. Okay, so these are conservative style categories. Now tell me one thing. You see, if you, let me just go to the next table. If you actually want to scale this up and you want to make this Z only the conservative category companies now your entire universe, what will be the scaling factor? Now, what I mean, what I imply in this case, understand this question very carefully, that you already know that you are in the conservative style category. So that has happened. You're only analyzing your conservative style category. And now I want you guys to make this conservative style category as your new universe. So it means if this entire thing is 12.5%, this total is 12.5, you can add them. 1 plus 1 plus 0.5, 2.5 plus 4 plus 2, 4 plus 2, 10, 10 plus 2.5, 12.5%. So all these are together 12.5% only. Okay. But now you want your 12.5% to become 100%, your new universe. Remember the same thing that we did in conditional probability visualization. So to make 12.5% into 100%, to change 12.5% to 100%, what do? You multiply,
Multiply by 8.
Multiply by
you multiply by 8. So just like in the conditional probability visualization, we were changing that 60% to 100%, and accordingly we were scaling everything else also. So if you are multiplying by 8 to make it 100%, so obviously all these probabilities will also be multiplied by how much?
8.
8. Exactly. So if you multiply them by 8, sorry, I just go to this slide. Yeah, if you multiply them by 8, you'll get this, correct? 8%, 8%, 4%, 32, 32, 16, 0, 0, 0. Agreed or not? This is what we are getting. Okay. So if you multiply them by 8, you are actually getting your new conditional distribution, you can say, where given that you are in the conservative style category, what are the stock returns and analyst ratings together? Okay, given that you are in the conservative category, given that you are in the conservative category. So now again, you relate it very beautifully to that conditional independence example. In conditional independence, do you remember in the first chapter, we had these three sets. First, we checked whether A and B are independent or not. Do you remember? Were A and B independent from the first chapter?
Yeah.
No. Try and recall the numbers that we had. I'll just recall the numbers. It was 3, 3, 3, 3 like this. Remember now? A and
Yes.
B were not
Yes.
independent. Yeah, A and B were not independent. But given a third event, C, they became conditionally independent. Do you remember now?
Yes, we did
Yes,
calculations.
exactly. So over here also, if you see the base table, if you see this table, when we talked about independence, were they independent? If you multiply this and this, are you getting this?
No.
No. So, not independent unconditionally. But once you have a third event is conservative style. We are only in the conservative style. Okay. Now check. Are they independent?
Yes.
Yes. So again, the numbers have been very carefully chosen so that you can understand conditional independence also. So the idea is completely same if you see. The only difference is that over there we were doing set theory. We were studying, two different events. Now we have a single bivariate variable which has two components. Now we are analyzing these two components whether they are independent or not. We clearly see that unconditionally they are not independent. But once we add a condition of conservative style, they become, and we change the numbers a little bit, then they become conditionally independent. Okay, because 20% multiplied by 40%, 0.2 times zero point 0.4 is 0.08. So these are conditionally independent. And what is the condition? Again, I'm repeating. Condition is independent. Condition is Z. Z is what? Conservative style. Okay, now I'll just come back to the previous table. So basically, since these numbers were chosen for the 12.5% part, so obviously for the remaining 87.5% part, these numbers have to be there naturally. Because if we are only taking 1% from the total of 20%, oh, from here, okay, total of 20%, but in the conservative style category, the joint probability is only 1%, then obviously the remaining 19% will go in the other style categories. Okay. So if you add all of them, you will get 87.5% together. Obviously. So that is why it is written. The overall probabilities are consistent with the original matrix. So that was the idea, but it's not very important. The main part was this only, conditionally independent. Okay. Fine. Last slide. So any collection of random variables is independent and identically distributed, or IID, if each random variable has the same probability distribution as the others and all of them are mutually independent. So what do we mean by this? Same distribution. Same distribution means what? They are being generated from the same univariate distribution. It can be any distribution. It can be normal distribution or any distribution. So practically say, let's say you have, you obviously you can do it on Excel quite easily using the different random functions or norm functions. Okay. Having the norm RAND function as an input to the norm function. But since random numbers are not truly random, it will still be pseudo random. But anyways, that's not a part of the course right now. I'll not go into that. It's a bit more mathematical. But as of now, you understand like this. You have a distribution and you have, let's say in the form of distribution, you have 10,000 observations and it's a discrete distribution. Forget normal distribution. Okay, just to make sure you understand it properly. Uh, you have chits. You understand chit, right? That small pieces of paper in which you write numbers and you fold them. Understand that? Chits, which, I mean, many students in their earlier school days, many of them used in their exam also. So those kind of chits. And let's say we have chits where we have all the numbers of the distribution written. Okay. And that all those 1,000 chits are there in a big bag of plastic. Okay, and you take randomly, you shuffle them, you take, put your hands inside. Okay, you cannot see them, of course. If they are inside, you put your hand inside, you take any one of them out randomly, and then you keep them back. You repeat this process. So obviously the distribution is same every time you are drawing a new observation. It is from the same sample, right? Same distribution. So same condition is understood. And they are independent of each other because since you have kept the chit back, then one of the outcomes is not influencing what will occur in the next trial. Okay, So they are same distribution and they are independent. Now, what are the features? What are the features of these IID sequence of random variables? Of course, independent, they will be independent. They are from the same distributions, but they will also have the same moments. Okay. And this property is very important. Expected value of a sum of IIDs is equal to n multiplied by expected value of each I, because expected value of each IID is mu only. The distribution is having the same every time you take out the the chit. Obviously, the numbers will be different, but the expected value of distribution is still the same, right? There's no difference in the expected value. And the variance of these two can be proved quite easily. The expected value is nu. The variance is equal to n sigma square, and these two will be used heavily later on, especially in VAR. So make sure you remember this. Do not get bogged by the notations. Again, I'm saying notations are not very important. See, expected value of sum of n independent variables, n IID variables, is equal to n times expected value of each IID variable. That's it. Remember it like this. Expected value of sum is equal to n times mu. Even for variance, variance of sum is equal to n times sigma. So you're just scaling it up, as simple, because there are a total number of n variables, right, which you are adding. So it's very simple. It gets scaled up by n. Even the variance gets scaled up by n. So my last question is, which will be used again heavily in VAR. If variance gets scaled up by n, what will standard deviation get scaled up by?
Root n.
Very good. And
Root
this
n.
is used heavily. This is actually used quite heavily. Okay, fine. So that's the end of this lecture. Thank you very much. Anything you want to discuss in this?
Yes, sir. A request. Hello.
Yes, yes, please go ahead.
Sir, while watching the videos of QTA 5, no, so
Mhm,
from the beginning itself, there were terms like bias and uh, some other very intimidating terms.
mhm,
Like I don't remember.
mhm,
So could you just while during the lecture,
mhm.
could you just explain like what is bias or maybe give some
That is why,
example?
today, in fact, it's a very valid question. That is why the class lecture of sample moments is very different from the video. Okay. So in the class lecture, most of those notations are gone and you have to focus on that only.
And even in that, no, there were two different videos, one short one and one old one. So I
Correct.
first watched the old one.
Mhm,
So now it was like a bouncer. So when I went to the shorter one, so
mhm.
even in that, like the terms were not like they were intimidating.
Don't worry, we will make
Mm,
sure that whatever
mm,
gap was left in understanding, we will try and understand each and everything in the class. So whatever you found intimidating, make sure you discuss with me in the next after the break, okay, in the sample moments class, and
yeah.
we will explain each and everything. Don't worry, okay.
No.
But for sample moments, there I totally agree that there are actually, because we had to follow the convention of GARP, you never know what kind of questions they ask. That's why
Mm,
we have just given those notations, but in the class we are very exam specific, and we make
mm.
sure to reduce the number of notations as much as possible, and even if there are notations, we will make sure that you understand it. Absolutely, don't worry about it, Parth.
And the class PDF would be enough for exam, right?
Yes, absolutely, it would be enough. It would be
Thank
enough.
you.
Okay. And also, see, one thing is very important, that whenever there are formulas and notations, I generally tell you guys that okay, no need to remember. So even in sample moments, if there will be such kind of formulas or such kind of notations, when I say don't need to understand or don't need to remember, then you can ignore it. No problem at all. Otherwise, whatever is important from the exam point of view and even from the conceptual point of view, we
Mhm.
will understand each and everything, the meaning of those notations. Okay, Parth, don't worry at all. Okay, so thank you very much. So we just end the session now. Anything else from anyone regarding this QTF 4 only? Okay, thank you.